Alright, hello. So it's the evening of August 3rd. A couple nights ago, the Cygnus spacecraft, it's an uncrewed cargo vehicle, launched out of Virginia, and it's actually up here in low Earth orbit with us, chasing us down right now. And tomorrow morning, Frank Rubio and I are going to be assigned to fly the space station robotic arm in to grapple the vehicle, and then the robotic arm will berth the Cygnus vehicle to the Node 1 Nadir hatch, which is right behind me. So we'll have a lot of new supplies tomorrow morning, as long as we can successfully grab that vehicle with the robotic arm. So this is one of two robotic workstations we have on the space station. The other one is actually in the cupola. We have a great view from the cupola, and that's actually where we'll do the operations tomorrow morning, looking right outside as we work. But this is our backup RWS, or robotics workstation. We actually have two power strings on the robotic arm, and we have these two workstations, and we can switch back and forth between these if we have an issue on the other one. Here at the robotic workstation we have three cameras. They're not quite set up yet for tomorrow's capture, but we typically have a center camera looking right at the target that we're moving the arm into, and then we have two side cameras that give us a bigger overall situational awareness view of what the arm is doing. And then we have the hand controllers here. So on the left is the translational hand controller, 3 axes, so up, down, left, right, and in, out. It just moves the arm in, out, left, right, and up, down. And then on the right we have the rotational hand controller. We can pitch forward and back, roll left and right, and yaw left and right. And that's changing the orientation of the end effector of the robotic arm. And then we have our display and control panel here with a bunch of switches that we use as we get into some of the operations. We can move cameras through that and deal with some backup modes for actually capturing the vehicle. Now, behind the robotics workstation, we have a workstation that we use for practice. This has an acronym that's actually ROBOT, but it's really our robotic trainer station. It's a similar setup. We've reproduced those 3 monitors up here. The center one is the one that we're really focused on as we drive into the vehicle, and then bigger situational awareness views on the outside. And down here we have some of the PCS, or space station computer pages, that we typically have up during these operations, where we can issue commands to the ISS. And so tomorrow Frank and I will go through a lot of operations to get the space station ready, and then we will get the go eventually from mission control, telling us that we are go for approach to capture. We'll set up actually the space station attitude control systems, get changed right before we do the capture, and then we will get hands on hand controllers and start in. And so at this training station we do 2-meter runs, so this is actually pretty far in on the approach. And what I'm going to be doing, the fixture that the arm is grabbing onto is right here. It's a pin with 3 cams sticking out from it, and the arm comes in to grab it. And as it does that, up here above, there is a target. And so my goal is to fly in and right up to that target to a certain depth. And I have some target markers here that help me assess how deep I'm going, and also assess alignment to the target. But big picture, we want these center green crosshairs on that target, and you'll see a small pin inside a small circle on that target. That pin is what tells me my orientation relative to that target, and I want it to be centered. I'm going to go ahead and get this going. So we'll unfreeze dynamics.
And free drift, go for approach.
And the vehicle is now simulated in free drift. So I start by getting a feel for what the rates are on the vehicle, mostly the translational rates. I'm at the same time watching what's happening with that pin over time to see if I'm going to need any orientation corrections. I'm trying to let my oscillations damp out from moving the arm. I see we're going to need a little bit of roll, so I'm going to start feeding that in gently. And I think we need a little bit of pitch up, so I'll start feeding that in. And with those open loop inputs in, I will start forward toward the vehicle. And now it's just a game of detecting errors and putting in very small changes to correct them. So I see I need to continue a little more roll, and I do see I need to be a little more aggressive on pitch. Now when you put in a pitch input with your right hand, of course that makes the target go up in the view, so you need a corresponding translational down command on the z-axis with your left hand, so you kind of get the feel for coupling those together eventually. And my control inputs are like super small, and that's just to avoid any oscillation in the arm.
1.5 meters.
This is looking pretty good, pretty stable.
Meter. Two pins.
2 pins, we're going to continue.
One pin.
1 pin, continue.
Over the pin.
Over the pin, looking good. Coming up into the capture envelope, trigger. Hands off the hands controllers and the snares inside the latching end effector. Grab the pin in this simulation, and then the end effector begins the process of slowly reeling tension back on the carriage inside it, and that's what ultimately achieves a hard connection between the robotic arm and our lovely new Cygnus vehicle. So this is great training, and that's probably one of the last runs I'll do. I'm going to get a good night's sleep tonight and get up tomorrow morning ready to work with Frank to get ourselves a Cygnus. See ya!